Hey guys, James here, and welcome to another Chemistry 151 GLA. Today we're going to be going over problems A and H in section D of GLA number 7. The instructions read, write both the complete and net ionic equations for the balanced chemical reactions below. What's nice about these problems is that the reaction itself is already balanced, so we don't have to worry about that. All we have to do is give the complete and net ionic equations. So first we'll give the complete equation. And we can do that by splitting up the reactants and the products into their smaller constituent parts. We have to label each part with its appropriate charge, and we have to state what phase it's in. So we'll go ahead and start over here with the potassium iodide. We know we have two potassiums, and each potassium has a +1 charge, and it's in the aqueous state. We also know we have two iodides, and those have a -1 charge, and they're also in the aqueous state. For the second reactant, we know nitrate has a -1 charge, and we have two of them, so I'll say we have two nitrates. And those have a -1 charge, and it's also in the aqueous state. Because the nitrate has a -1 charge and we have two of them, we know that this lead molecule right here has a +2 charge. So I can say we have one lead molecule with a +2 charge that's in the aqueous state. And that'll take care of the reactants. Next, we have to do the product side, and I'm going to start over here with the solid. Because this is a solid, we don't have to split it up into the constituent parts. We can just say that it's going to stay as a solid. And then going back over here, we have the two potassiums with the +1 charge in the aqueous state, and we also have the two nitrates with the -1 charge in the aqueous state. So this right here would be the complete ionic equation. To go from the complete to the net ionic equation, we're just going to do a little bit of canceling. Anything that forms the solid is going to be in the net ionic equation. If there is an aqueous molecule or compound on the reactant side and the product side, we're going to go ahead and cancel that out. So as you can see here, on the reactant side, we have two potassiums that are in the aqueous state, and they both have a +1 charge, so we'll cancel those out. Next, we have the two nitrates with the -1 charge in the aqueous state, so we'll cross those out. And this is where you'll see the net ionic equation. It's going to be Pb with the 2+ charge in the aqueous state, reacting with the two iodides to yield the final product, which is the solid lead-2 iodide. And so that's going to be the net ionic equation for this problem. Next, we'll go ahead and look at problem number H. Just a little hint on this one. The mercury that is here is going to stay in the diatomic form. And so what it's going to actually turn into is an Hg2 with a 2+ charge on it. So that is the tricky part to this problem right here. It's not going to turn into two Hg's with each one having a +1 charge. So this is what it's not going to be. So we can go ahead and give the complete ionic equation like we did in the previous problem. We're going to say that this is going to stay as Hg2 with a 2+ charge, and it's going to be in the aqueous state. We know we have the two nitrates with the -1 charge on them in the aqueous state. Here we have the two potassiums with a +1 charge in the aqueous state, and we also have two chlorides with a -1 charge in the aqueous state, producing the solid over here that we're going to keep together because it's not in the aqueous state, it's a solid, so it's not going to break apart. And then we have the two potassiums again with the +1 charge in the aqueous state, and the two nitrates with the -1 charge in the aqueous state. So that would be the complete ionic equation. To go from the complete to the net, all we got to do is cancel the same things out that are on the reactant side as the product side, like we did in the previous problem. So the potassiums will cancel here. The nitrates will cancel here. And the net ionic equation will be Hg2 with the 2+ charge in the aqueous state, reacting with the two chloride ions that have the -1 charge. And when those two react with each other, that's where you get the solid formation of Hg2Cl2. And so that would be the net ionic equation. And that's how you do problems A and H on GLA number 7. I will see you guys next time.